Alright, today we are back at System of Equations, and today we're going to focus on graphing linear inequalities. We did inequalities before, but it was just on a number line, so today we're taking it to the coordinate plane. But first thing I want to talk about is how do you know if something's a solution to a linear inequality? Well, it's the same stuff as before, you're just going to plug in that ordered pair. So for our first two examples, we're going to plug in our x and y values to see if it's a solution, to see if it's true. So remember for our first one, we have 2, and then it's greater than 1 minus 3. Well, what's 1 minus 3? Negative 2. Is 2 greater than negative 2? Yes. So it is a solution. For the second one, you have negative 3, which is your x, and negative 7, which is your y. So let's go ahead and plug that one in. You got 2 times negative 3 minus negative 7 is greater than 3. Well, let's see what we got. So 2 times negative 3 gets you negative 6. When you subtract a negative, it changes to a plus. So you have negative 6 plus 7, which gets you 1. So we have 1 is greater than 3. Is that true? No, it's not. So that is not a solution. So that's kind of similar to what we've done before, is just seeing if it's true or false. And that determines if it's a solution or not. So let's keep going. Let's graph some inequalities. So the biggest thing I want you guys to see is this is your example. So you got some steps. You got to graph the inequality. You got to tell me if it's dashed or solid. And as you see there, if it's a greater than or a less than sign, that's going to get you a dashed line. But if it's, less than or equal to or greater than or equal to, that's going to get you a solid line. So that's kind of the first main step, and it's easy to miss if your line is dashed or solid. Your step 2 is to find a test point. We're going to use 0, 0 a lot of the time unless the line goes through the point at 0, 0. But we'll talk about that in a bit. And then lastly, you got to shade your graph. But that'll happen after you test your 0, 0. So for example number 1, we've got y is greater than x minus 2. So as same as before, this is your b. That's where it crosses that axis. So there's a point at negative 2. So now we got to do our slope, which is 1. So that's 1 over 1. So up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, or down 1 back 1, down 1 back 1. Alright, so remember, we got to figure out if it's a dashed or a solid line. So if we look back, it's a dashed line if it doesn't have the equal to sign next to it. So for example number 1, which we're doing, it's going to be a dashed line. So it's going to be a dashed line through those points. Still put your arrows. Well, now we got to do our test point. So what I want to do is plug in 0, 0 for my x and my y. So 0 is greater than 0 minus 2. So let's do the math. If 0 is greater than negative 2, that is true. So what that means is you want to shade the point 0, 0. So our point 0, 0 is right here. And we want to shade this side of our graph. It's kind of just coloring it in. So that's our first example. Let's go ahead to our second example. So we've got a inequality, and it's in standard form for what we know with our linear systems. So we need to find our x and our y. So for our x, we've got 3x is less than or equal to 12. So we know that we're going to graph our x value, if we divide both sides by 3, at positive 4. And our y value, so you got negative 4y. Negative 4y is less than 12. Well, when you divide by negative 4, we know our y value will be at negative 3. So let's graph those 2 points. You got 1 at 4 and 1 at negative 3. So we got to figure out if this is a dashed or solid line, and as you can see it has the equal to, so that means it is a solid line. Don't forget your arrows. And now we got to do our test point. So remember our test point, we're plugging in 0, 0. So we've got 3 times 0 minus 4 times 0 is less than or equal to 12. Well, anything times 0 just gets you 0. So it's saying 0 is less than 12, which is true. So you want to shade 0, 0, which is right here. So you want to shade this side of your line, the side that makes all the values true. So anything you plug in that shaded side will get you a true inequality. All right, let's go to our next one. Example 3, example 4. Oh snap, remember we've got our vertical and horizontal lines. So for our first one, we have x is less than 1. So remember that's going to cross your x-axis at 1. Well, is this a dashed or a solid line? It doesn't have the equal to, so it's going to be a dashed line at 1. That's a jacked up arrow. All right, now let's do our test point. We're going to plug in our 0, 0. So it's saying 0 is less than 1. Well, is that true or false? That is true. So you want to shade 0, 0, and that's on this side of our line. All right, example number 4. We need to graph y is greater than 2. So remember, that's going to cross at your y-axis at 2. So that's going to get you your horizontal line. Well, is this going to be a dashed or a solid line? Well, it has the equal to sign, so it's going to be a solid line. Now we got to do our shading. So we're plugging in 0, 0. So we've got 0 is greater than or equal to 2. Is that true? No, that is false. So you don't shade 0, 0. So 0, 0 is on this side of the graph. You don't want to shade that side, so you're shading the other side. And that gets you your solutions. Everything that's shaded are your solutions. All right, well, what happens if you're given a graph and you got to write it? Well, we got 2 examples to cover that too. You're welcome. All right, so a lot of the times it's easier to write things, in your slope-intercept form of where it crosses your y-axis and where it goes given from that point. So for this first one, we know we'll have y, and you'll have some inequality symbol that'll go here, and then you'll have kind of the rest of your equation. Well, let's fill out the rest of that equation. We know it's going to cross your axis at -1. So we know that's -1. And let's look at a point. We have a point here. We have a point here. So what's our slope? We go up how many? 2. And we go over how many? 1. So that means our slope is 2 over 1 x. Remember, your slope is always paired with x. So now we got to figure out, what the inequality symbol is. So remember, if you're plugging in 0, 0, you're going to have something like 0 and -1. Well, because it's shading 0, 0, you know that the inequality has to be true. So we know that 0 is greater than -1. And we see that it's a dashed line, so it's not going to have a equal to sign. So we know that our inequality that we're just going to write is y is greater than 2x minus 1. It can be tricky, but like I said, break it down step by step and see, what the graph is actually telling you. All right, let's go ahead and look at the second one. So we know we'll have y, our inequality sign, and then something. Remember, our inequality sign will go there. So where does it cross your y-axis, I ask? Let's see, at this 1. So we know that's going to be our +1. That's how we're getting that value. Well, let's try to find our slope. So we have a point here, and we have a point here. So we're going down 1, so that's -1, and over 2. So with our rise over run, that's going to be -1 over 2x. Because remember, your slope is always paired with your x. And then lastly, you got to figure out what your inequality symbol is. So when you test 0, 0, you're going to plug it in. So we're going to have 0, our 1/2 x, that's going to cancel out. And then we'll have +1. So we have 0 and +1. Well, we see that the graph is not shading 0, 0. So that means the inequality is false. So because it's false, we know it's going to face 0 because 0 is not the bigger number. And we see that it's a solid line, so we'll have the inequality, have the equal to with it. So y is greater than or equal to -1/2 x plus 1. Alright, those can be tricky, but please, like I said, break it down as much as you can. But that's it for this video. Go ahead and check that off, and I'll see you later.